Hey there, my name is Manav Sharma and I'm an SAT tutor. Back in high school, I got a perfect score, and ever since then, I've been helping other students prepare for their SAT. And this is basically a video to help out with that. I've had a lot of students struggle with the circles on the SAT. They are a very common shape that is tested. I'd say basically on the same par as triangles and squares, so they're definitely up there in terms of the importance of the content on the exam. So, with that being said, let's dive into some of the content that you're going to need to know when beginning to study this topic. All right, let's talk about circles, right? Circles are a very interesting and important shape within mathematics. We can start by knowing that they have 360 degrees and that they also have zero sides, right? However, that's not the most special thing about circles, because actually a lot of other shapes also have these properties of having zero sides and 360 degrees. One of those things is the oval, right? This oval here that has 360 degrees and it does have no sides. So what mainly differentiates a circle and an oval and what makes a circle so special is that every point on the edge is equidistant from the center, which is here. So this red line, as you can see, is much shorter than this blue line here. And on a circle, that is not the case. So you can see all these points I've written here, all these random points. You could draw basically there's an infinite number of points, and all of them pretty much have the same distance to the center, right? And this distance is called the radius right here. And its older brother is basically the diameter, which goes through the center of the circle. This could be diameter here, as long as it goes through the center and intersects 2 points. Something to note is that the diameter is double the radius, right? So those are three properties you should be very familiar with. Zero sides, 360 degrees, and all points are equidistant from the center, right? So let's move on with a couple of formulas that are really important for you guys to know. So these are probably the two foundational formulas over here. It's the fact that the circumference, right, is the length around the circle, and that the area of the circle is a space inside the circle. So these two have formulas that I really recommend memorizing. It's C equals pi d and A equals pi r squared. So I have a great mnemonic to remember these. It's cherry pies are delicious, and then apple pies are too. It doesn't make the most sense, to be honest, but I've clearly remembered it since middle school, so it must have something to it. So yeah, that's basically where that comes from. These are really foundational for the SAT, since a lot of the concepts we'll be talking about and a lot of the questions you'll see build on this property, right? So with that being said, let's move on. This is a step up in complexity and equally as important. This equation here is the equation of a circle on a graph, right? So this is x minus h squared plus y minus k squared is equal to r squared. What this equation accomplishes is that it will allow you to take any circle and basically plot it on the xy plane, right? Just like we plot parabolas and so on, right? So all you really need to plot a graph, right? Let's think about it for a second. What do we need to plot a graph real quick? We would need two pieces of info, really. We would need, let me just drop my quick and rough plane here. But really what we would need is, okay, where's this centered, right? Where is this circle centered? And how big is the radius? Because if we know the radius, we can kind of approximate, that it'll be something like this, right? And that's a lot better. So with those two pieces of key info, we can pretty much draw any circle very accurately, right? And that's exactly what's represented by this equation here. So the two pieces of info you need to fill this in are the fact that HK is the center of the circle, and that r squared is represented by r, which is the length of the radius, right? So one thing to note is that they are being subtracted here, the h and the k. So the signs that you will see in the equation are actually the opposite signs that they actually represent, right? So if you see x minus 2 squared plus y minus 2 squared, that actually refers to a center of 2, 2, right? So another more popular formula that you should know is the length of an arc, right? And let's quickly do a small exercise to explain the formula. Real quick, it's arc length is equal to circumference times arc degree over 360, right? So what is an arc? Arc is basically, you could think of it as if you have a circle, right? Or let's say you have a pizza. The length of the crust is kind of the arc. Say you have this slice, say it's an irregular slice. The length of the crust here is known as the arc, right? And this length over here, this distance is known as the arc length, right? So we stated earlier that a circle has how many degrees? 360, right? So say this circle has this length, right? That is 180 degrees, which is very conveniently half of the circle. And this circle has a circumference of 100 pi. Well, then we pretty much can say that this is 50 pi. So if you said that in your head, you pretty much came up with the formula yourself. Because the arc length is simply the circumference times the angle over 360. So this is basically refers to what fraction of circumference does this take up. This takes up half of the circle. So the length is also going to be half. So that's kind of how that comes into play. All right, so there we go here. And then this is something that's more of a utility. There's many questions I will ask you to convert between radians and degrees. And pretty much all you need here is to know what to multiply by. Radians are much more likely to have pi in them, right? For those unfamiliar with radians, hopefully you are familiar with the concept of degrees. And I tell you to think of radians and degrees just like inches and feet, right? So they measure the same thing. However, they're just different units. Not much else to them, right? And the same way you can convert to inches from centimeters, you can also convert between radians and degrees, right? Common radian measurements look like pi over 2, pi over 4, pi over 8, etc. Degrees can be anything: 90 degrees, 45 degrees, 37.225 degrees. These are all very valid. So if we want to convert from radians to degrees, we multiply by 180 over pi. And if we want to convert from degrees to radians, multiply by pi over 180, right? So I have really bad memory, so I figured out a way to always know which one to multiply by, since I tended to mix them up in my own studies. But say we have radians, right? We have, for example, something like pi over 2 radians, right? And I don't know if I want to multiply by 180 over pi or pi over 180, right? But I know that this radian measurement is going to have a pi that disappears, right? Because the degree measurement, it doesn't usually present with a pi, right? So I know that if I have to cancel this pi out, I have to multiply by something that has a pi on the bottom, right? So to get rid of that, I will choose 180 over pi. And then we end up with something like this, which was just going to be 90 degrees, right? 90 degrees. Oh, what also stands, if you have something like 45 degrees, right? You know that you have to probably add a pi in somewhere, so put the pi on the top, and then this becomes 180 on the bottom, and then you can get something like that, right? This is pi over 4, right? This is 1, and this is 4, if I reduce that real quick. So some quick memorization rules there. And then finally, tangent lines is a concept that you will see on the SAT that you should keep in your back pocket to help you solve questions, right? So you should know that a tangent line is basically a line that meets some object at one point, right? And let me draw a quick example. So let's say we have this circle, right? Normal circle. And then we have this point here. We can have this point here and this one here. So these are all examples of tangent lines. So this line here is a tangent line because it meets at one point there. This is a tangent line because it meets at one point there. Move this around a little bit. And this is also a tangent line that is at some point there. But what they are is, if we draw a point to the center, they're all tangent to that point and have a right angle here, right? So they have a right angle to the line that connects from the point that they touch to the center. So this point here, the radius essentially that this forms, they're always perpendicular to that, right? So this is a very useful fact that you can use and take advantage of when solving, because if you know that these are perpendicular, right? These, like for example, these green lines, and you know that these red lines are perpendicular, and you have the slopes or even points of one of them, that's very powerful, right? Because we know that perpendicular lines have negative reciprocal slopes, right? So if we know that this one has let's say this line here has a slope of 2, we know that the negative reciprocal, which means that we have to flip it and negate it, right? That would give us a slope of -1/2, that is, right? And just for another example, we can see that if this has a slope of -2, then we know that this line here has a slope of 1/2, right? So we flip it over here, which gives us a 1/2, and then we negate it. So over here, it's already negative, right? So we just flip the sign back to positive, right? All you're doing when I say negate is multiply that by -1, whatever the original sign is, right? So just flip the sign. So yeah, there we go. That being said, let's hop into some questions and let's see how to solve, right? So let's see. A circle in the xy plane has equation x plus 3, y minus 1 equals 25. Which of the following points does not line the interior of a circle? So we can do this very algebraically, or we can just plug this into Desmos, right? Okay, so there we go. And then we can continue to plug in the choices. Our first choice is -7, 3, and let's see if, okay, that's in the interior of the circle, so we can move on there. We can try -3, 1, -3, 1, let's see. Let's just keep going down the road. That's 0, 0. We have here 0, 0, and then we have 3, 3, 2. So which of these doesn't lie in the interior of the circle? The green one clearly does, so we can get rid of that. The lavender one clearly does, and this black one here, choice D doesn't, right? So that tells us that our answer here is simply choice D, right? So that one's not too bad. Let's take a look at this. A circle has center O, and points A and B lie on the circle, right? The measure of arc AB is 45 degrees, and the length of the arc is 3 inches, right? So what is the circumference in inches of the circle? Let's draw the circle here real quick. I've done these questions for years and I still draw it out. The pro there is honestly a lot of the time, like not in this situation, but many other questions, you'll find that just by drawing it out, you'll literally find the answer within a couple of seconds, which is really cool. But yeah, let's get started. So they're saying that A, B lie in the circle. So let's draw those out. And luckily we know that A and B form a 45-degree angle, right? And then they're saying that this arc over here is 3 inches, right? And let's quickly just draw out our formula to see if we can solve this quickly, right? So our formula is arc length, which we already have, is equal to circumference. This would be angle over 360, right? In degrees, right? So we know arc length is 3. Circumference we're not sure about, so let's just call it x. And let's call the angle 45 over 360, which, spoiler alert, is 1/8 x. And then to solve here, we divide by that, which means we multiply 3 by 8, and this is 24, right? So our choice is choice D over there, and that's the correct answer. All right, let's move on. So, okay, let's see here. An angle has a measure of 9 pi over 20 radians. What is the measure of the angle in degrees, right? So let's take a look here. So this is 9 pi over 20. And to convert this into degrees, we have to multiply by something that's going to help us get rid of the pi over here, right? So let's multiply by 180 over pi, so we can cancel these pi outs. And then we can say this is 1, and basically just reduce a little bit and to get that. And then we can multiply and get 81 degrees here. Okay, so in the xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle, right? So what is the radius of the circle? Okay, so there we have our circle. We have plotted our equation. We can quickly click on the top and the bottom of the circle and kind of save those points there. So over here, right, I would only trust the top and the bottoms of the circle. These ones over here will not always be directly across from each other. As you can see, it's actually a little bit above. That's not a perfect diameter there, so it wouldn't really help us find the radius, right? But that being said, we can click on the top and the bottom, and we save them right here, tapping the gray icon next to them. And then what we can do is we actually have a distance function somewhere here. There we go. And then we can use those there. So that's our first one. That's 1.5, 4.5, right? And then comma for the second point, because we want to find the distance between it. We can say 1.5, comma, negative 5.5, which is that there. And then we can see already that our distance there is 10, right? Which would make our radius 5. So our answer is 5 here. All right, so again, this is another radian question. So it's a 720 degree angle over here. And we basically want to convert this to radians. So let's do 720. And at this point, I'm sure you understand that we have to multiply by that, by 180 over pi. Let's see over here, 720 divided by 180 is 4. So we know our final answer of 720 degrees is 4 pi radians. And we know that the format of this is a pi of our final answer. So a must equal to 4, okay? All right, that one's not too bad. Let's talk about this one. So this is a question that says, a circle in the xy plane has its center at negative 4, 6. And line K is tangent to this circle at negative 7, 7. So what is the slope of line K? Before even doing anything else, let's draw it out. Let's draw that there. And then it seems like they say our center is at negative 4, negative 6. And then, so we have a tangent to this line at negative 7, 7, which means it's going to be somewhere down here, right? This is just an approximation. Negative 7, right? Because it's lower and to the left, right? Than relative to this point. And they're saying there's a tangent line, so it should be something like this, right? Something like that. Let's take a look here. This is line K. And they want to know the slope of line K. And how would we know that? If you recall earlier, we know that these lines have to be perpendicular, right? Tangent lines onto a circle are always perpendicular to the line that it starts from where it touches the circle to the center, right? So it's perpendicular. Do we know anything about this line over here? We can actually find the slope of that, right? And which is helpful because perpendicular lines have negative reciprocal slopes, right? So what's the slope of this line here? Let's find out. Change in y over change in x. So change in x. So change in y is -1, and this is -3. So the slope here of that line is 1/3. This slope is 1/3. 1/3, which means that the slope of line K, if it's negative reciprocal, is going to be 3 over 1 times -1, which is going to be -3, right? So it's going to be -3. There we go. Cool. All right. So I hope that makes sense, guys. Let's move on. A circle in the xy plane has diameter with endpoints 2, 4, 2, 14. So here's the next question. An equation of this circle is x minus 2 squared plus y minus 9 squared equals r squared, where r is a positive constant. So what's the value of r? So as a reminder, that this r in this circle formula that's represented here is the radius, right? So this is purely the radius. And like always, before we hop into the math, let's do some drawing, right? So let's draw this out here. So this is saying that this circle has endpoints 2, 4 and 2, 14, which means that they're stacked above each other, right? In the same on the same, x coordinate, right? So it looks something like this: 2, 4, and then 2, 14. Do we already know anything about it? Yes, we know the diameter, right? Because we can kind of approximate the distance by just looking at this, actually. We know that the distance is going to be exactly 10 here, right? Because the distance between these 2 points is going to be 10. The x coordinate is the same, and the y coordinate is just added by 10, right? If we know that the diameter is 10, and we want to find the radius, we know that the radius will just be simply 5, right? So there's a question there. All right, so thank you everyone for attending, and if you would like to see a longer version of this, please drop a comment below. Thank you.